Good morning. My name is Flavia Riccardo from the Istituto Superiore di Sanità, the Department of Infectious Disease of the Institute of Public Health in Italy. And I'd like to thank you for this opportunity to talk about arboviruses in humans. And I will do that looking at examples and perspectives from Italy. So I will try to convey arboviruses as a public health problem, looking at it from the human health side, with examples from Italy of recent outbreaks from mosquito-borne diseases, using one example from an endemic disease, so a disease we see every year, and an example from a non-endemic disease, so a disease we don't usually see. And I will try to then describe a little bit what integrated surveillance and response looks like at the national level in Italy and how Italian plans have evolved in terms of arboviruses in the past 10 years. So when we look at arboviruses, the reason why we're worried about them from a public health and human health side is that they can cause severe disease in humans. So, for example, neuroinvasive diseases, so diseases causing, for example, meningoencephalitis, that can be also fatal, have been described for a number of arboviruses. A lot of those are endemic in Italy, such as West Nile virus and Untitled virus, which are transmitted by mosquitoes, tick-borne encephalitis, which is transmitted by ticks, and Toscana virus, which is transmitted by sandflies. But we're also worried about other arboviruses which are not endemic. We don't see them every year, but we're worried that they might be imported. And these are such as chikungunya, diseases like dengue and Zika. And those can be potentially transmitted by the tiger mosquito, which is an exotic mosquito that was imported in Italy and now can be found everywhere pretty much. So the reason why we're worried is that we could import them. These could be locally transmitted maybe in Italy, and these can not only cause diseases that can be quite severe. For example, dengue can give a viral hemorrhagic fever in some cases, or can cause extensive pain and can be disabling in some cases, such as chikungunya, but also in the case of Zika, can cause a rather mild disease in the person getting the disease, but in case of pregnancy can be transmitted to the fetus, causing congenital malformation. So this is something also that we're worried about. So there are a number of issues around arboviruses that have a potential impact on human health. But of course, when we talk about arboviruses, we talk about complexity. Complexity because of the natural transmission cycle. So we know that these are diseases that are transmitted by vectors. They can be zoonotic diseases, for example, West Nile. So there can be an involvement of one or more animal species, plus they will involve humans. Their main route of transmission is through the vectors, of course, but there can be also rare transmission through other routes, for example, through transfusions and transplants. So there is a concern about ensuring the safety of transfusion and transplants. There is complexity, therefore, also not only in surveillance, which has to take into account all the different species that can get infected, but also in response, because we have to take into account not only vector control, but also blood transplant safety, behavioral changes in the population that can reduce the exposure to the vector, for example, and therefore the risk of transmission. There are activities, for example, prevention activities that can be conducted in the animal health and not for human health. If we think that West Nile has a vaccine for horses, but there is no vaccination available for humans, and so forth. So we are talking about a number of different actors. In addition to that, of course, these are highly seasonal diseases. Because the vectors themselves have a period of activity that is highly dependent on the environmental context. And this, I think, really opens a great opportunity in terms of collaborating beyond the health field to try to understand which parameters could be better predictors of an increased risk of transmission for the different diseases in order to not only act as early as possible when transmission starts, but also to be able to prepare in advance and prevent some of those conditions being there and favoring the transmission itself. So looking at the drivers and identifying what actions we could do, being informed of those drivers, then could really change the way we approach and prepare for the seasons of transmission. This slide shows where West Nile virus was detected in different species over time in Italy. So we find, following a first detection of the virus in the late 90s due to the animal health sector, we have now areas where we have constant viral circulation, so the virus is found year after year, and areas where there are sporadic cases of infection, so we find it maybe 1 year but not the next year. We think that the virus first arrived in Italy through the migratory birds, but now we're looking at multiple endemic infection cycles that involve medium and short-range migratory birds, resident birds, and probably local infection foci that reactivate when the environmental conditions are favorable. And this is where we can see the number of human cases of West Nile neuroinvasive disease over the years from 2012 to 2019 in Italy. And it's quite clear that 2018 was a very bad year for West Nile. Not all the years are the same, as you can see. In that year, we had an early start of West Nile virus transmission, a higher number of cases, and a protracted duration of transmission, with cases being reported throughout the month of October. And this is highly unusual for Italy, as you can see. The overall number of confirmed cases was 618 in the country. Of those, 244 were severe. We had 49 deaths. We also detected the infection in blood donors that their blood was not used, of course. So this was a way to avoid the risk of transfusion-related transmission of the disease. Cases occurred mainly in the provinces that had that transmission before, but also in new areas. So there was also an expansion, geographic expansion of viral circulation. And there was a discussion, of course, of early warning when it comes to these unusual years. So in Italy, as I will show in the next slides, there is an enhanced integrated surveillance that involves the istituti zooprofilattici, so the animal health institutes throughout the country that take care of, in the case of West Nile, animal health and mosquito surveillance, and the Institute of Public Health on the human side that I represent, that monitors the disease in humans through the regions, of course, and local health units. And this provides us with an advantage, because what we have seen is that the virus is detected earliest in the mosquitoes and in the birds, and then later in the season you will find the cases in humans and horses, which are dead-end hosts for that disease. And in 2018, this actually is what happened. So we had the first case in a positive mosquito bull on the 7th of June, so in early June, and then later that month in green here we see the first human neuroinvasive case. And both the early detection in the birds and the first neuroinvasive case in humans had occurred very early, so we hadn't had that detection before in the past. We always started pretty much around July. So we knew in early June that this was going to be a bad West Nile season. So this activated a number of measures on the substances of human origin, so safety of transplants and transfusions, routine and extraordinary vector control. But there was also a question about whether we could have triggered those actions even earlier, considering that there had been, retrospectively, we found that there had been anomalies in terms of temperatures and humidity in the spring in those areas. And the driving idea is that those have somehow favored vector activity, favored early transmission, amplification of the virus, and therefore the higher circulation with a spillover than on the human health. So the question is, if we have those parameters beforehand, could we do something, for example, be more aggressive in our pre-season and initiate beginning of the season vector control actions to mitigate the impact that those conditions have made possible in terms of the transmission of the virus? So could we act even earlier than the earliest detection of the virus circulation? And this is an opportunity in terms of opening up to other disciplines and other expertise. Moving to our second example, so in this case we're talking about a non-endemic viral disease, chikungunya in Italy. So chikungunya is endemic in other countries. In the in Africa, in the Indian subcontinent, Southeast Asia, and the Pacific region. It is transmitted by other mosquitoes, not the common mosquitoes like West Nile, so not Culex mainly in Italy, but by mosquitoes of the Aedes species. And what worries us in Italy is that chikungunya was found to be transmitted by the Aedes albopicto mosquitoes, which is the tiger mosquito, which is, as I said, now found pretty much everywhere in the country. And we found that through outbreaks. So we've had 2 outbreaks of chikungunya. One in 2007 in the northeast of the country with over 200 cases. At that time, we found the outbreak was fueled by mutated virus. So we kind of felt more relaxed by the fact that, maybe this mutation had made it easier for the virus to be transmitted with our mosquitoes, but that the likelihood of having a mutation happening or a circulated mutant strain was a question of high or low probability of that introduction and local transmission. But then we had another outbreak 10 years later, much larger, with almost 500 cases in 2 regions, one in central Italy, one in the south of Italy. And at that time, aside the fact that we had a late detection for the virus, mainly due to the fact that we're not used to thinking of chikungunya as a cause of arthritis, arthrosis in older people with no travel history. So definitely that is something that didn't help us in the early detection. This also led to a reevaluation of the risk of actually having chikungunya outbreaks locally in Italy, because this of course was the second time it happened, but it was the first time that we had a multifocal outbreak, and in that case the virus that circulated in 2017 was not a mutated virus. It was the virus that was circulating in Southeast Asia at that time. So the initial idea that this mutation somehow had made the virus more capable of being transmitted was somehow not confirmed the second time. We found that our mosquito was probably quite able to transmit chikungunya even without that mutation. So it suggests that we have widespread and effective transmission dynamics happening that are not driven by mutations within the virus. This led to a big change in our plans and a lot of training activities to try to make us more efficient in responding to every single imported case, not only of chikungunya actually, but also of other diseases such as dengue and Zika, and to react even more rapidly should there be a suspected transmission happening locally. So just wrapping up in the last presentation, I'd like to show you a little bit how the evolution of the plans in Italy has occurred with respect to arboviruses. So following our first West Nile outbreak with human cases in 2008, there was a big revision of the way the surveillance was being done, because the surveillance systems were in place, but they were mainly parallel between the human and animal health sector. Since 2010, we have a national program for West Nile neuroinvasive disease surveillance that integrates information from the veterinary and vector surveillance systems. And discriminates, of course, different areas within Italy in terms of the surveillance strategies, considering endemic and sporadic areas of transmission. And in 2011, we introduced chikungunya dengue, in 2014-15 Zika, and surveillance of blood donors. And in the following years, there was a more definition of a more structured West Nile virus response plan that became West Nile and Uzutu. In 2017, there were introduction also of tick-borne encephalitis and Toscana virus surveillance, and increased robustness of the components related to surveillance and response for the safety of transfusion and transplants. And these were all plans that were updated yearly, and that as of 2019 there were 3 different plans that were circulating parallelly for West Nile and Uzutu, for chikungunya, dengue and Zika, and for the non-mosquito transmitted arboviruses. Since 2020 we have now a 5-year plan for arboviruses in Italy that takes all of those into account and builds on even more on the prevention activities from vector control, communication, information, education, community engagement, and so forth. And this is a higher level plan, so it has the possibility of triggering more actions in addition to what was already being done in terms of surveillance and response. And this 5-year plan will have annexes that can be updated, more frequently and evolved. In terms of the surveillance, so what does it look like when you have integrated surveillance? I'm going to bring you just an example from Italy, looking at diseases transmitted by vectors that have an impact on blood and transfusions, transplants. So mainly arboviruses, but you will also find malaria being mentioned here. And I'm going to show as little clouds when people are connected through a common platform, and as a green line where the communication happens within the Institute of Public Health from the human side. So this is an integrated system, and we're just going to look at it for this presentation from the human health perspective. So if we start with a human case, which is on the human side, we often start with that. A case will be reported by the region or the local health unit, and laboratory samples will be sent from the hospital. And those will arrive in different ways. So depending on the type of disease that we have, West Nile Lesotho is notified through an online platform. Chikungunya, Dengue, Zika, TBE are notified through certified emails. And the same is true for malaria, which are then inserted and collated in a database in the Institute of Public Health. Samples are sent to the National Reference Laboratory for Arboviruses, and slides for malaria to the Malaria National Reference Laboratory. So for Arboviruses, there are 2 units within the Institute of Public Health, the ISS. One, the epidemiology unit where I work, and one is the National Laboratory, Reference Laboratory for Arboviruses. And then, of course, we're also in contact with the National Laboratory for Malaria. Every time there is a positive case meeting triggers that we have predefined with all the actors, we communicate with the National Blood Center. So they are within the Institute of Public Health still, but they are an independent center taking care of blood safety. And they are also informed by their subnational counterparts receiving information. We also inform the National Center for Transplants, again within the ISS, which then in turn informs their regional counterparts. We inform for West Nile Lesotho cases, we inform the Istituto Zooprofilattico of Teramo that coordinates all the animal health and mosquito surveillance for West Nile and Lesotho. And of course, we inform the Ministry of Health, and then information is then provided to the European Centre for Disease Control as is defined by the European Commission. However, of course, when we start from the human side, we arrive late because we start with the first human case. Triggers that I mentioned are a confirmed West Nile case, presumed clusters of chikungunya, dengue, Zika, for example, and those have been agreed upon. And this will trigger a number of actions, in particular on the control of blood and transplants, of international communications, and so forth. However, as I said before, there is an opportunity for some diseases which are zoonotic to have an early warning. And a good example of that is West Nile, because for West Nile, we can act upon positive animals and positive mosquitoes. And this happens thanks to these zooprophylactic institutes, so the animal health counterpart, because they do the surveillance for those species and provide positive results for confirmation to the Teramo Institute, that then communicates with the National Center for Blood Safety and with us, closing the circle. So basically we can be in touch and exchange information at all times. So this is what it looks like in practice when we talk about integrated surveillance and information exchange. So in conclusion, arboviruses are diseases that have a relevant and a high public health impact, but of course they're complex because of their transmission cycles and diverse epidemiology, so the way they are transmitted in different places, different countries, and also within the same country, as we have seen. So this leads to complexity also in the surveillance mechanisms and the response strategies. But of course, we know that there is a connection between environmental parameters and vector activity. So there is an opportunity, as I said before, in widening the scope, broadening the number of actors and disciplines that can contribute to better understanding what factors could be influencing the host, the vectors, favoring transmission, and therefore understanding earlier when we would be observing a higher risk of outbreaks and how to better act upon that. So again, I'd like to thank for this opportunity to talk on this topic, and I'm leaving also my email should you have any additional questions or aspects you would like to discuss further. Thank you very much.